Okay, class, today we're going to look at section 7.3. In section 7.3, they're going to have us solve equations. Now, we've been solving equations since chapter 3, but this time our equations are going to have fractional coefficients. We've got fractions. Most of you just said in your head right now, oh man. Now, here's what we're going to do. If you listen to me, I'll make it very easy for you. We're going to see that to solve equations with fractional coefficients, we multiply both sides of the equation by the LCD, and then we solve the resulting equation. So basically what we're going to do is the first step is to find the LCD, and then we use that to get rid of all the fractions. Now, Mrs. Burton has a word for everything. So when I'm talking about solving equations with fractional coefficients, my word is elimination in your best Terminator voice. Okay? So we are going to eliminate the fractions. And how we eliminate those fractions is by multiplying by the LCD. So let's look at the first problem that I've got up here. And if you look here, we've got an 8, a 5, and a 2 in our denominator. Now, we already know before I can add or subtract fractions, I have to have a common denominator. Okay? But what we're going to do, instead of messing with all that and making equivalent fractions, we're just going to eliminate the fractions. Now, we start out the same way, though. We've got to figure out what our LCD is. What would our least common multiple be? So when I look there, if you had 8, 5, and 2 in the denominator, what would you choose to be your common denominator? Yeah, that's right. We would choose 40 to be our common denominator. Well, now that we've done that, we're going to take that and we're going to multiply every fraction by 40. Now, we've got to multiply on both sides of the equal sign. So here we go. Let's take and multiply the first fraction by 40. Now when I look there, 8 goes into 45 times, so 5 times 7 is 35m. Now we've got to go over here and multiply this fraction by 40 as well. Well, 5 goes into 40 8 times. Okay, so 8 times 3 is 24. So we got minus 24m equals, and we've got to multiply this by 40 as well. So we're going to, 2 goes into 40 20 times, and 20 times 11 is 220. And look at that. Presto changeo. All the fractions are gone. And now we're back to something pretty easy that we can isolate the variable by inverse operations that we did back in chapter 3. So the first thing we need to do is we need to combine like terms. What's 35m minus 24m? Yeah, that's right. We've got 11m equals 220. And now, what do I need to do to get m alone? Yeah, we're going to divide both sides by 11. So what does m equal? M equals, and everybody says, 20. Okay, so the key to taking care of all these nasty fractions is to eliminate them. Now, the next slide, I basically showed all the work for one problem. So let's look up here, and here's my example. Here's my example. We've got x over 6 minus x plus 3 over 5 equals 1. So again, when I look there, what's my LCD? Well, if I have 6 and 5 as my denominators, my common denominator, my LCD has to be 30. So I multiply each fraction by 30. And something should cancel out every time. If you get a fraction when you're multiplying by the LCD, you did something wrong. So if you look here, we're going to multiply these two together, and that's how I got 5x. And then we're going to take the second fraction and multiply it by 30 as well, and that's where that came from. And then we've got to take the last fraction and multiply it by 30. So we've got 5x. Here we had 5 divided by 30 is 6. So now I took care of my distributive property there. My next step here, I combine like terms. And again, remember, we can't have a negative x if we're solving for x. It has to be a positive understood 1. So we get x equals negative 48. And then again, good algebra students always check their work to make sure they are correct. All right, so now let's you and I try a couple of these together. All right, so let's go ahead. Let's write down, everybody pull out your note sheet and let's write down this problem. Okay, and when you look at that and you think, oh man, fractions, what am I going to do? Well, what we're going to do is we're going to eliminate the fractions, elimination. And we eliminate those fractions by multiplying everything by the LCD. So let's look up here. If you had 2, 4, and 6, what would you choose to be your common denominator? Well, we're going to choose our LCD. Yeah, good job. My LCD is 12. So we've got to multiply everything by 12. Every fraction. So that means we're multiplying 4 different terms by 12. So here we go. 12 times x is 12x. And if you need to write it by each one, that's cool. We're going to cross cancel there and get a 6. And then we've got minus 6 times 3x is 18x equals. Now we've got to go over here and multiply everything by 12. We're going to cross cancel there and get 9x. And then we've got to multiply the last one by 12. And then that's going to give me 2 minus 10. Okay? All right, so now that looks pretty easy. We did things like this back in chapter 3. So what should I do next? That's right, we're going to go ahead and combine like terms on the front side. What's 12x minus 18x? Yeah, there you go. Negative 6x equals 9x minus 10. Now again, we're solving, we're using those properties of equality. Isolate the variable by inverse operations. So we're going to subtract 9x so we can get x's on one side. So now I've got negative 15x equals negative 10. And now what's my next move to get x alone? Yeah, I got to get rid of that negative 15. So I got to divide both sides by negative 15. So x equals, now did you realize a negative divided by a negative is a positive? Good job. And then we can reduce that fraction. What's my GCF between 10 and 15? Yeah, so this is going to become 2/3. So x equals 2/3. Okay, so the whole idea, get rid of the fractions. Now, we may end up with a fraction as our answer, which is what we did down here, but that's okay. The moves in between there are pretty simple, just like we learned back in chapter 3. Let's try another one, okay? Everybody copy this one down. Okay, now, how's this one a little bit different? Do I still have fractional coefficients? Yeah, I do. They expect me to do distributive property with those fractions, but oh, no, 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 no. We're going to get rid of those fractions. Okay, the whole idea is elimination. We want to eliminate the fractions to make it easier. So let's look. What's our denominators? Our denominators are 3, 5, and 3. So if you had 3 and 5, what would you choose to be your LCD? Yeah, pretty easy. That would be 15. So we're going to multiply everything by 15. Okay, so here we go. Now, so when I look at the first part, if I make 15 over 1, times 2/3, well, this will cancel and get me a 5. And so when I look there now, I've got 10 times x minus 1. We're going to multiply this by 15 over 1. And what are we going to get? Yeah, that's right. We've got a minus sign in the middle, and then we've got 3 times x minus 2. And then when I look at the last one, okay, we're going to get rid of that, and then that's going to give me 5 times x plus 2. So we eliminated the fractions. We don't have to do our distributive property with fractions. We got rid of them. We still have some distributive property to do, but this is way easier. So here we go. We've got 10 times x is 10x. 10 times negative 1 is negative 10. Ooh, do you see what's going on here? Did you check this out? Remember from long ago and far away? Yeah. So we've got negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Now we got to do the distributive property on the back side of my equal sign. So we've got 5x plus 10. Who thinks they know what we do next? Yeah, that's right. We're going to combine like terms. So we have, I'll get a different color, 10x and negative 3x gives me 7x. And then when I combine my constant terms, yeah, we've got negative 10 and positive 6. Negative 10 and positive 6. So that's going to give me what? Negative 4 equals 5x plus 10. And now here we are. We've got to isolate the variable by inverse operations. So let's put letters in the front. That's what I like to do. So I'm going to go ahead and subtract 5x from both sides. So I've got 2x minus 4 equals 10. And now our floater, okay, we got to get rid of the 4. So now we've got 2x equals 14. Ladies and gentlemen, what does x equal? Yes, x equals 7. Okay, so once you realize, hey, I can eliminate those fractions, once we get rid of those fractions, we're back to what we did in chapter 3, which makes life so much easier. Okay, now we've got 2 story problems to look at, and then we're done for today. So let's look at the first one. Okay, let's look at the first one. Ooh, they put something in there we learned this week. It said 3 numbers are in the ratio of 3 to 5 to 6. 1/4 of their sum is 1.5 more than the smallest number. Write and solve an equation to find the numbers. Well, what are we looking for? Remember step number 1 in the 5-step plan, because it's a story problem. Here we go. So we need let statements. Well, they gave me a ratio. Remember, we're going to use that ratio to as our let statement. So we're going to let 3x, 5x, and 6x equal 3 numbers. And again, we're just using our ratio that was given to write our let statements. Now, we need an equation. So what does it say? 1/4 of their sum is, there's is. What do we do with is? Is means equal. So 1/4 of their sum. How are we going to write that? Well, we need a 1/4, and then we need the sum of these, so that means we're going to add them all together. Now, 1/4 of their sum, so I'm going to go ahead and put a parenthesis there, plus 5x plus 6x is means equal 1.5 more than the smallest number. Well, 1.5, okay, 1.5 more than the smallest number. Which one of those x's is the smallest number? Yeah, 3x. Good job. Now, the first thing I would do is I would change this to an improper fraction. We're going to get 3/2 plus 3x. And then over here I have 1/4. Now, oh man, we've got fractions in this problem. How in the world do we solve a problem with fractions? Yeah, that's right, elimination. Hey guys, if we had 4 and 2 as our common denominator, what would we solve everything? What would we multiply everything by? Our common denominator would be, good job, it would be 4. So we've got to multiply everything by 4. So here that all cancels out, say yay. All right, so we're left with what? 3x plus 5x plus 6x. Okay, now we still got to go over here and multiply everything by 4. So this is going to cancel and give me a 2. So we've got 6 plus 12x. Everybody understand? where all my numbers came from? Okay, good job. I need just a little bit more room. Okay, so now what do? Yeah, we got to combine like terms. If I add all these x's up, what do we get? Well, we've got 8 and 6, which is what? 14x equals 6 plus 12x. Got to get those x's together. So I'm going to subtract this 12x over here. And so now I have 2x equals 6. Hey guys, what does x equal? X equals 3. Okay, so same idea, just being good detectives like we've learned. Okay, now what do I need to remember to do next? Yeah, I need to remember to check it. So we've got 1/4. So we've got x is 3. So 3x, 3 times 3 is 9, plus 3 times 5 is 15, plus 6 times 3 is 18, equals, I'm running out of room, 3 halves times 3 times 3 is 9. Okay, so let's see what we've got here. Let's add what's in this in the parenthesis. If I add all those numbers together, what do we get? Yeah, we get 42. And then here, if I multiply that, I'm going to get 9 times 3 is what? 27 over 2. Oh, it's supposed to be plus, not add, not multiplying. Mrs. Burton ran out of room, and then I didn't write the right operator down. Okay, so we've got 3 halves plus 9. Okay, and we're going to change that 9 to 18 over 2. So we've got 21 over 2. So 42 over 4 equals 21 over 2. And that's true, okay, when we simplify that bottom fraction. So the check on that one was a little tough, but we got through it. Okay, now last story problem of the day. Let's go ahead and go to our last slide, okay? Now, it says Terry spent 3/5 of her monthly salary on rent and 1/3 of her monthly salary on food. If she has $400 left, what is her monthly salary? Okay, so we've got to figure out monthly salary. So that's what I'm going to make x. Let x equal her monthly salary. So mom and dad, Mrs. Burton gets paid at the beginning of the month, and I've got to budget it all out, okay, to take care of rent and food and transportation. So let's see. So that means she gets paid her salary. So we're going to go ahead and make that x, okay? And it says she spent 3/5 on rent. So if you think it's spent, what's our operation going to be? Yeah, we're going to have to subtract. We're going to subtract 3/5 x, 3/5 on rent, and 1/3, she spent 1/3 on food, okay? And it says she has $400 left. Everybody kind of understand what I did? Here's how much she gets paid. Okay, that's her salary. This is what she spends on rent. This is what she spends on food. And this is how much money she has left. All right. Oh, we've got fractions. How are we going to solve this equation? Yeah, we're going to multiply by the LCD. Pretty obvious. If we have 5 and 3, what are we going to multiply everything by? 15. Good job. All right, so here we go. 15 times x is 15x. If I multiply this by 15, we're going to get minus 9x. And then if I multiply this by 15, we're going to get minus 5x equals 400. All right, now let's see what's left over here when I combine like terms. Okay, well, we've got 15 minus 9, which is 6, and 6 minus 5. Guess what? We've got x equals, what did Mrs. Burton forget to do? I forgot to multiply the 400 by 15. All right, let me fix that. What's 4 times 15? 60, right? So we'll make this 6,000, okay? And since these all cancel out, guess how much her monthly salary is? $6,000. Now, there's a couple like that tonight for homework, all right? So, tonight we're going to work on fractional coefficients. And again, the name of the game, elimination. Good job.